Okay, so what we're trying to explain is why it is that when hunters and gatherers, which all our ancestors were, when some of them started to become farmers, so to do agriculture, what we see is that the remains show that they were probably much worse off in per capita terms, in the sense that they had more instances of arthritis, which show us that they were working harder than they used to, that they had higher rates of infection, which shows they were living in more cramped conditions and probably also had a poor diet, and they were also shorter, which also suggests, growth stunting might be because they're not having enough food when they were children. And the current explanation for this focuses on one or another variant of a population trap. So the idea is that either population was slowly increasing, and at a certain point there was just no choice but to become farmers to feed this population, or people were in an equilibrium, then they decided to settle. By settling, they increased their fertility rate. This meant there was more population and they had to become farmers. Or they became farmers, they settled down, their population increased, and therefore they couldn't go back, but now actually they had, in per capita terms, they were worse because the population increase was larger than the original increase in food, which was what they were after. I might redo this. What I'm instead going to say is that what's key here is the seasonality pattern. So the idea that you have different amounts of food during the winter and during the summer, but you need food in both periods. So a lot of what you will do will be a way of limiting your susceptibility to volatile periods and to seasonality in particular. The general argument could also be in terms of food which is in some way storable, or if it's available, more or less at the same time during the year, such as perhaps wildlife in certain environments. Then it could be that it's fluctuations that are in the longer term, but we're going to focus on seasonality. So we take a look at our first graph. So what the idea here is that there's these two environments. There's a valley and there's a mountain. And there's two seasons, there's winter and there's summer. And the two types of environment have food at different times. And specifically, the way we're going to show this on this graph is that we have here the amount of food that is available in the winter time, and here the amount of food that is available in the summer. And our endowment, this is an endowment economy, so if you control the territory, you get it for free. Our endowment economy is going, our endowment vector is going to be somewhere on this graph. And this line here, which I drew at 45 degrees, is the zero seasonality line. So why this is important is because this is the line at which, of course, these two values are equal, which means that it's the line at which you get the same amount of food throughout the year, and there's all this model collapses on this line, and this is most other models are explainable in terms of movement here because there's no seasonality. So there's other dimensions which I'm not discussing, but as far as this graph, they're all on this line. We can see here what I have in mind in terms of the endowments. This darker line is the valley. So the valley, during the winter time, it has a lot of food, but during the summer there's droughts and there's less food, and it goes up and down and up and down. And then you have the mountain, which is this lighter line, and this is there's more food during the summertime when there's less food in the valley, and there is less food during the winter because it's all snowed in. And these are, of course, all just hypothetical examples, and it's not important that this is the, it could be the reverse, it could be wildlife passing through at a specific month, or it could be even like the spawning of locusts or whatever at specific periods. It doesn't really matter. What matters is that there is some variation throughout the year, and that this variation is reversed in another neighboring territory. This is what is key. So how do we show this? What do we need food for? What do we need food for? So food, we need it because we want a large population. The reason why we want a large population is, well, first of all, If we have too small a population, if it reaches 0, we're dead. So, the further we are from that, the further we are from being extinct. That's pretty good. And another thing is that there's no property rights or UN peacekeeping force. So we have to defend our territories against neighbors. And the larger our population is, the more we're able to do this successfully. In fact, if the population is large enough, we might be able to challenge the control of their territory, which would allow us to expand our line. So this is sort of an evolutionary argument. We're going to argue that people want to maximize population because the ones that don't have been selected against by evolution. And basically the idea here is that each period is of course 6 months. It's a season. It's 2 seasons, but centered on summer and on winter. And there's no ability to store food from one period to the other. And you need food. Specifically, you need the same amount of food in both periods. And what this means is that if there's not enough food in one of the 2 periods, the population dies, which means that the largest population it will be able to sustain it will just be equal to the minimum of the 2 endowments of food. So it's basically going to be a Leontief production function because all these points are going to have the same population. If you're down here, if you have a lot of food during the winter, but not a lot during the summer, you're going to be constrained by the amount of food you have during the summer. And this, conveniently, we can just say that for any point, we can just read it off the 45-degree line is going to be basically our population vector because it tells us what it is that people are after, so to speak, in the sense that that's just something I said. No, what it tells us is simply it's a way of having it on the same line, so we can immediately compare 2 different vectors by seeing where it is that they intercept. If we have a vector here and a vector over here, we can see which one will have the largest population by reading off vertical and horizontal lines, respectively. This is just another quick thing to explain a little bit more how this graph works. So the idea is that these lines over here, which you see, which are 45 degrees lines with a negative slope, slope of -1 in fact, these are lines that have the same endowment throughout the year. So these are all lines where the 2 sums are the same, so of course it's a 45-degree line sloping backward, and the more you go up, the more food you have. While instead, as you get away from the 0 seasonality line, what you're doing is you're increasing seasonality. So these are iso-seasonality lines. All these points will have the same amount, the same ratio of summer endowment to winter endowment, and they're going to also have an interpretation in terms of standard of living, which we're going to get to in a moment. And now we're able to get the intuition from this graph and carry it over to our main graph. So the idea is that this is the valley, and the valley has more food clearly during the winter when there's no drought, and instead during the summer there is much less food, as you can see here. So it's below the 45-degree line. And the amount of food you can have is of course equal to, we can read off the 45-degree line, and this is the n is population, and this is the population that you're going to have for a band which exclusively lives in the valley. We're not allowing them to move back and forth. If instead they had been living in the mountain, so the mountain has more food during the summer and very little food during the winter, and the population you can have is here. So if you have a choice of which of the 2 places are both unoccupied, you can occupy one. You're going to want to be in the valley because the population is higher than in this case, than in the mountain case. If instead we allow them to be nomads, then you get the best of both worlds. Because you get to be in the valley during the winter, so you get this vector, and you get to be in the mountain during the summer, so you get this vector, so you're able to effectively have this endowment profile over here, given your choice of strategy. What's your population going to be? Your population is going to be here. Of course, you read it off the 45-degree line as usual. And the tricky part, no, not the tricky part, but the interesting thing